Hello, folks. So, welcome to this webinar. Today's topic is Sight Beyond Sight, the benefits of observability in QA. Okay, and today we are having Leandro with us. He's a dev advocate at Grafana Labs. Before starting, folks, a huge shout out to Browser Stack, our exclusive sponsor for all our community events and premier sponsor for our conferences. Perfect. Now I will invite Leandro on the stage. Okay, I'll just call up on the stage. He can give us a quick intro. Oh, Leandro is here. That's amazing. Hi, Leandro.
Hello, hello.
Yes.
Hey, can you hear me? Can you see me?
Yes, I can see you. I can hear you
Okay,
properly.
yeah.
Well, first of all, welcome, Leandro. And Leandro, you can give the audience a quick intro about yourself, and then we are good to go.
How about we go through because part of the presentation is an intro.
Sure,
So,
that works. That works. Stop.
okay.
Yeah.
So let's get ready for the show today. Oh, it's only me now. Hi, everybody. I think while the display of my slides appear, welcome. I am Leandro Melendez, also known in the internet worlds as Señor Performo. Um, I come today to talk to you a little bit about a topic that, well, lately it has got some attention. It has become more relevant. I am a dev advocate for this topic, which is observability. And today I'm going to be talking a little bit about what is this thing called observability. What is it? How to use it? How does it taste? Is it good? Is it bad? And well, I'm going to also share some tips on how our QA teams could get some benefits out of the observability practices, principles, everything that is around this. So um, I'm not sure if the slides are showing already, but um, let me know if you can see them. I don't see them here on the feed. Uh, 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 um, okay, I think. Am I not sharing my screen? Oh, I think I need to share it. My bad. So sorry for this. Okay, and I'm here. Sorry, Aaron, that I made you come back to the stage. Yeah, I thought that this was already being shared. So, again, welcome to this talk that we're going to have around observability. First, as I was mentioning, who is this guy with a mustache talking to you directly from Mexico City? Well, again, I am Leandro, also known as Señor Performo. I'm a dev advocate with Grafana, a company that specializes in observability, traces, metrics, and everything that you may need to enable the observability. And we're going to be talking a little bit about Grafana today. I'm not trying to sell Grafana to you. I'll give you some tips around it, but uh, don't worry, this is more for you to learn about this cool thing that is observability. So moving on with me, I started this Señor Performo thing with the blog. Then I was invited to start a podcast in Spanish, Perfects Español, which after a while, I am also co-host of the English version, Perfects, just Perfects. I also have a couple of YouTube channels, Señor Performo ENG for English, ESP for Español, Spanish. To be honest, lately I've been producing more content in the Spanish channel around performance testing, Prometheus, interviews for testing positions and specific for performance. I'm working towards having them at the very least subtitled. And when YouTube enables, I may have both languages for you to take a look. If you like the content, like, subscribe, and all those YouTube things. I also am a presenter. I tend to be on online events like the one that you are attending right now. And some other times I also get on stage and present on conferences, events, workshops, and forgot the name, meetups in local events. So look around. I may be appearing on some of those conferences. And last but not least, I have created a book around performance testing, the hitchhiking guide to load testing projects, which explains a traditional load testing project with lots of examples so that you get a better experience understanding these complex topics that are performance testing, load testing specifically, with these cool examples like, well, a Mexican. The examples include tacos, puppies, my mother throwing a chancla at me, and things like that. I, if you like it, there's a link. I'm showing a QR code with all the information. Scan it, check it out, and go to all the links. Add me to all the social networks that are listed on that link. Feel free to write up if you have any questions for the things after this. I'll be more than happy to follow up. But enough about me. What are we going to be talking about today? What is going to be the menu? So first, I'm going to get into some definitions so that we know what is what. We call a spade, and we get deeper into this observability rabbit hole. Then I am going to share some cool things that we can do in QA with these observability capabilities. And last, we're going to close with some tips. I'm going to give you some recommendations of what you can do to start leveraging the powers of observability. But first, what is observability? How do I eat it? Does it taste good? What do I do with it? So let's give a definition first of what is observability. Let's go with a somewhat dictionary definition. Observability is the ability to deduce the internal states of a system from information that is available externally outside of the system. This sounds a bit confusing, if you ask me. It's not as straightforward, this definition. If you give it some thought, you may figure out what it is, what it's telling. But I like easier examples. My deal, my thorpe is to always provide examples. So, but before we move to the example, observability has another way of referring to it. Olly, it's sometimes referred as OLLY, but the LL is not an LL, it's an 11. That means that's because we have the O at the beginning and a Y at the end, and 11 letters in the middle, just to make it shorter. So if you hear the term Olly, refers to observability, this capability and these principles to be able to deduce the internal states of a system from the information that is available externally. So what does this mean? So here are some examples so that you understand what is observability, so that we get a better definition. To me, the internal state of the system, and it can be any system, a car, weather, IT systems that we are developing, any system, you can know the state of it using data that is outside without having to get off and lift the front hood of your car and check the engine. Without getting off, you can know how much gasoline is still in the tank. You don't have to stick your finger in the tank and check how deep is the gas. You don't have to get off your car and use that pivot thing that we used earlier to check the tire pressure. Or if the engine has a problem, you will see this light turning on in the dashboard of your car. A dashboard is a key component of observability. So the key of observability is that you can know the state of your system, your car, without getting off it, without looking into or doing too much. It's available to you and visible and easy to work with it. And this is not the only thing where you can implement observability. It can be implemented on so many things that you would be surprised. One example that I bring you, you can see it here, our weather app. Generally, you don't have to go outside and put your hand, bring a thermometer if it's raining, how's the wind or anything. You don't have to go outside your home to know what is the weather out there. We have our apps in our cell phones that will tell us, hey, there in Mexico City, you have 19 degrees Celsius. It's very cloudy. It might rain. at 3 p.m. The wind is blowing at 14 kilometers per hour. And all this information useful for me because if I want to go outside, should I bring a sweater? Should I bring an umbrella? It's important that I have this observability of the weather. Another cool thing, if I wanted to know what is the weather of, I don't know, a remote location, I could check what is the weather easily with these applications. Let's say, I don't know, New York, New York, New York, New York. Oh, wow, it's kind of warm over there, 28 Celsius. It's sunny. It won't rain. It's similar windy to Mexico City. And we can check all this from a distance. I don't have to travel to New York. I don't have to do all this because we have weather observability. Some other examples is like the stock market. You don't have to go to Wall Street and get inside of there and, hey, what's the price on, I don't know, NVIDIA? No, you can just check your app because it has observability about the stock prices. And at a distance, you can view all this. It's on your bank accounts. You know how much money is inside of them. It's on your health trackers. You know how fast your heart is beating without putting your fingers in your neck. And all this is really cool. But, well, how do we get it? How do we get to achieve observability? We need a few components. First, we need telemetry. Telemetry is very important for observability. We achieve it through instrumentation. We also need some storage, and we need to be able to do some monitoring. And well, these terms are fancy and cool, but what do they really mean? So, first, let's check the first one, telemetry. Telemetry is the capacity of a system to transmit the information. It's like these shoes. You can be far from them, but you know what is the status of the shoes. They have this capacity of a distant transmission of the state. They will send you some metrics that you can um, not read but identify. And these shoes are strong or they are fairly clean. And I'm not referring only like just bad smell. They can be just brand new shoes and that plasticky smell of a new pair of shoes. That's telemetry. The shoes are transmitting their status. You can tell if they are old or if they are new or if they are very badly used in the gym and they might be, yeah, better be washed. You can tell using that telemetry. But how can we achieve this telemetry? Because we can not only put it on shoes, we can also put it on systems, on the car example. Again, the car, the gas tank is transmitting how full or empty it is. That's a transmission. And how do we achieve this transmission? Well, we have to instrument the element that we want to observe. This instrumentation is very similar to the act that a doctor does and puts a stethoscope on your heart. The doctor doesn't have to tear your chest open or he just put the stethoscope on your heart. And that device, the stethoscope, will enable transmission of the sound of your heart. Similar to what you will get, we all probably are instrumented with these smart devices, these smart watches, that once we install them in our wrist, like software installation in ourselves, these devices will measure all the statuses that we are interested on, like the smell on the shoes that we were talking earlier, your heartbeat, your blood pressure, your oxygenation. Somehow they can also detect how many times do we breathe per day. I still don't know how do they do that, but these smartwatches are instrumenting our bodies. This instrumentation, again, think of installing a measurement system inside of the gas tank of our car, installing something that measures the number of spins that the wheel does and translates it into speed, how fast is the car moving, and many more things. In software, we can instrument our code and enable it to send these metrics or information that we are interested on measuring. Now, with the example of the smartwatch, if I am on the gym and I am on the treadmill and I'm very sweaty and like I quickly want to check, okay, yeah, my heartbeat is probably 140, or I'm in a very good shape and it's only 110, even if I'm on a treadmill after several minutes. That's it. I just read it and I don't need more. But some of these smart devices can tell us, like, hey, you're getting better. Your heartbeat is getting slower when you are on the treadmill. Or, hey, you may have some heart issues because I'm checking your history for last year and check it out. Some of these details, when we check it just once, it's just like, oh, I got a reading. That's all I care. But if we need to do some analysis into the future on how is the health of the system, our bodies, well, we may need storage. We may need a location to put these metrics, these readings, this information. Señor Performo, the heartbeat at 8 a.m. was just having breakfast, was cool, so 70 beats per minute. When he was running toward the bus to get to the office, well, it was 150 because he was, and we have a historic of what has been happening. That history, we need to be able to store it. And this storage is interesting because we have different mechanisms. These measurements are mostly for later use. If it's something that we just care right now and like, I don't know, the weather, most of the time we just care about the weather when I'm about to go out and to know if I should bring a sweater or an umbrella or bring shorts and sandals. But, and that's it. Sometimes we don't need more. But when we need to store it, like say, let's do a prediction for next year, next summer, how is the weather going to be? We may want to store it. There are two mechanisms for this in observability: pushing the information from the with the telemetry, or pulling that telemetry information. What does this mean? The device that stores, let's think of a database, a CSV file, a log system that is receiving the information. It's a push. The system is being pushed the information towards it. Think of a database. It's just making an insert. But this is useful only when, let's say, probably my smartwatch is pushing information into a small database that it has here. But that's when the data is just me. Imagine if all of my family was sending the data to this watch. Pushing it might be too much. Performance testing, the bottleneck may appear pretty soon. So, in these situations, when you have too many things and you don't care second by second, so these devices, the instrumentation and the telemetry is just published. Here it is. Like, let's say the stock market price. Here's the stock market price. Do you need it? Come and pull it. So the push situation is just, yep, I grabbed it every 5 minutes, every 10 minutes, whenever I need it, install instead of being bombarded by all the data. So these two are important if you need this information for later use. Now, all this information at times, if you have seen the Matrix movie, uh, sometimes this information can be like those foreign characters that you saw falling down the screen. And you're like, wow, there's a lot of information there, but I don't know what it is. So the next point of observability is monitoring. This information, this code that fell on the matrix all the time, well, what is it? So we need an interpreter. We need a way that we human beings can make sense of all the metrics, all the readings, all the things that our telemetry, our instrumentation is providing. And generally, this is achieved through dashboards. If I had only the numbers from my car going at this velocity, I don't know. But if you have this gauge meter that is moving and telling you, oh, it's going too fast, or the revolutions in the engine are too many, you may want to switch gears or take it to another speed. Well, we need this visual interpretation, easy for us human beings to see, to understand what is happening. So here's an example of a full system that you may experience on your daily life with observability. So some modern cars that, well, all the cars have tires, but some modern cars have some instrumentation inside of the tires. These instrumentation are pressure sensors. The pressure of the tire, so that you know if you have a low or flat tire or the tire is doing well. These sensors transmit, have some telemetry being sent to the car's computer. Depending on what is the type of information, here I'm giving you the example of tire pressure. Probably you don't want or need a historic set of values of what has been the tire pressure of your car. You just care about right now, what is the pressure? But let's say the fuel tank, if you need to do a projection, hmm, My fuel has been decreasing this much while I move this long, the distance or the velocity that you're moving at. So, probably from that historical set of measurements, the computer of the car with a database, because cars have databases, it can tell you, yeah, according to your average use, and you have 10 liters of gasoline, you may be able to go this far, 50 more kilometers probably. I'm just bringing out numbers. It's not, I don't know car efficiency. All that information is being displayed at you in the car's dashboard in ways that are easy to understand. If I told you, yeah, the gas tank has, I don't know, um, 300 kilopascals of gas pressures, and you're like, what does that mean? I just want to know how full or how empty is the tank to know if I should put gas on it. So with this dashboard, it's easier. Now, how does this translate into systems? Because yeah, you have heard me talking a lot about cars and all this, and you must be like, okay, IT. Well, here's an IT related example. With client libraries or agents, we manage this instrumentation. We can install an agent on a server. We can install a client library on a Java solution that we are programming. And with this, they will transmit the status. But not only that, not only infrastructure or application or programming languages, you can also install or add a client library to a Playwright script, to a Selenium script, to many automations that we may have in testing, so that these automations transmit their status. The server, the system, and the testing automations do telemetry, transmit this HTTP status, and we can store it in a database. Popular databases that are out there: Prometheus, InfluxDB, Splunk, Jaeger, Elastic. Here's a concept of time-based databases. They just store records, no tables. They have measurements instead of tables or metrics, and you pull them out of it. And speaking of pulling data, then we generate the visualization, because here in the database, we will end up with a lot of logs and Jibber and metrics and stuff. So if we pull it from a visualization platform like Grafana, like Kibana, like Honeycomb, Splunk, and many others, we will be able to generate this relevant information and even see it live, which is super important. So I mentioned a few elements out of this that you were like, "Mm, traces, logs, what?" So observability uses mainly three types of data. Some innovative people, crazy people are bringing out a fourth pillar, but we have the traditional three pillars of observability: logs, metrics, and traces. So what are each one of them? Logs are registries. So just a line of text, lots of plain text indicating what happened. Let's say 8 a.m. Leandro woke up and served a cup of coffee with, I don't know, 400 milliliters of coffee. But all this is text. Then he entered his car. He went to the gym. And in the gym, he was on the treadmill for 10 minutes, only 10 minutes. But all of this is records of text. This text is not so easy to index because, well, making a search on just text is kind of complicated. But the advantage is that the logs have a lot of information inside of them. Not easy to process computationally, but they have a lot of information and can be varied. Sometimes it can be just Leandro woke up 10 a.m., that's it. And some others is Leandro ate at lunch, I don't know, 400 grams of beef with, I don't know, it's a burger with two buns and cheese and blah. It's not similar at all from the first log of the day, just woke up. Now, the metrics are specifically values, numbers. These values can be paired up with labels. These ones are mostly numbers. Rarely you will see text as a metric, but mostly is numbers or statuses: true or false, or on off, yes or no. That's it. And you can store this information like, I don't know, the lights inside of my office. At 5 a.m., turned on the lights. At 5:30, turned off the lights. At 6:10, turned on again. So those are the statuses, and those count as metrics. What we do for the metrics, we pair them up with tags, and you know what you are looking at. A big advantage for the metrics, they are faster to search because we have the tasks. You can list them, you can modify them. But a disadvantage is if I gave you like, hey, what metric do you have? 4. Okay, what's up with that 4? What does it mean? They don't tell a story, they are just numbers. Now, on the last corner, we have traces. Traces are a bit better because they tell a huge story. They can tell you, like, yeah, let's say we have spans, and those time spans is where we are going to generate a trace. The time span of Leandro's morning from 6 a.m. to, I don't know, 9 a.m. At 6 a.m., woke up, went to the bathroom, then went to the kitchen, boiled water for 2 minutes to prepare coffee. These events, let's say the database of the boiling coffee, it's a separated device than the Leandro device that we have instrumented and we are observing. We want to know how long did the coffee pot database took. It was 2 minutes. So we can separate that story step by step on what is that we have. Again, the traces are the heaviest ones of this tree. You should not generate too many because they mix logs and metrics and they link them together with an ID. So they can take lots of space. Easier example, logs. The logs come from the ship captain's log. I'm a pirate and I have a log of what ships we have attacked in the airports or in still ships, trains, transportation were the ones that started with logs. Commerce as well. In storage unit, we have a warehouse or something like that. Okay, yeah, 3 pounds of sugar got in. I don't know, Jack took I don't know, 10 beans out of the storage unit, and so on. It's text. We are just taking records of what is happening with logs. With the metrics, as I mentioned earlier, we have the on and off status. We can have numbers. We can have some binary identification, although it's a little bit not advised to have binaries. Numbers, 10 seconds, 1 mile, 10 pounds, 50% of CPU, 10 seconds for postback, 10 errors, things like that, just numbers. And in the traces, as I mentioned earlier, are steps that tell us a story. If you see here, this is a visual representation of a step. The line at the top is Leandro's morning from 6 a.m. to 9 a.m. And this is the getting ready, let's say, as an example. This is getting out of house. And the smaller elements and components, you can dig into them, and it's very good to analyze. So what tools do we have for observability? There are a big variety of tools that we can use. Each one of the functions, metrics, components, traces, all these things that I have been mentioning, there's a tool for that. You may be wondering, like, is a tool that does everything? Yes, could be, but in general, it's a mix and match. Whatever you need, you can pick it up. As an example, in the instrumentation, there are client libraries that you can implement inside of your software. Java libraries, Python libraries, I don't know, C Sharp, or even JavaScript libraries that you may be using, I don't know, in Selenium, Cypress, Playwright, LoadRunner, K6. Some of these tools have libraries. Some of them are not official, but Prometheus, this one with the flame, and OpenTelemetry are some of the most popular lately. There are several that you will find out there in terms of libraries. Now, we have agents as well, which is a software that you install in your server or computer or whatever you want to observe or generate this instrumentation. Those agents will get inside of the software, pull all the information automatically. Generally, they are quite transparent. You install it, you configure it, and you are getting instrumentation and metrics generated telemetry. Uh, as I mentioned, I work for Grafana. You can use the Grafana agent named Alloy, similar wordplay with Oli, Alloy for observability. Datadog and Dynatrace also have agents. And once you generate all these information metrics, you can store them. There are several solutions where you can store. The most recommended is to use a time-based database, which can be like Prometheus or InfluxDB. But internally, many of these solutions, you have also Jaeger for traces. Grafana has lots of solutions: Loki, Mimir, Tempo, for storing Loki for logs, Mimir for metrics, Tempo for traces, and then later you can visualize it. Dynatrace and Datadog also have some of these capabilities, but once you have the data, the information, you need to visualize it. The visualization, there are multiple solutions. Grafana, again, is the one that you see on all the steps because wants to impact all the stages. Elastic can be good with Kibana to do the visualizations. Dynatrace, Datadog. You may say, hey, Elastic, I think it has a storage. Yes, it has a storage. It has some agents and instrumentation, but I'm bringing you the ones that I think are better or most popular. Elastic has some situations, but it's useful if you want to use it. In terms of visualization, the big problem for many organizations is to connect the information to the storage, because sometimes you will have, I don't know, this is a Microsoft SQL database, this is a Prometheus one, then we have InfluxDB, now we have Access, or even some have CSVs. So Grafana, I'm going to quickly show you. This is, I'm showing you here. I hope that you can see it. I don't see it. I think I'm just sharing the application. Give me just a second to reactivate this entire screen here. Okay. This is Grafana. I hope that you can see it well. Grafana is a platform that will allow you generate a lot of these dashboards, a lot of these visualizations. We have solutions also for, again, storing logs, storing metrics, storing traces. And something really cool, if you want to play with it right now at this moment without any steps, you can go to play.grafana.org and you can start playing with it. You will see the screen that I'm showing you at the moment. Grafana is open source. So as well, you can download the Grafana binaries and start playing with it right now. No cost, no compromise, just start playing with it. So here inside of Grafana Play, I'm going to create quickly a dashboard to show you some of the capabilities in terms of visualizations and so on that you can generate with it. So if you have, again, as I was saying earlier, where is this? Okay. If you have stock market data, you can see it here. I don't know if you can see it clearly. I think that the screen is showing pretty dark, but let me know if you cannot see it. You can see here the variations with a time series. There are also bar charts. You can also watch it as a gauge. You can also watch it as a status. Even if you have it a pie chart, well, this is not the best representation of a pie chart. Let me see if I can quickly show you a cool. Here's a pie chart that you can quickly configure. So you connect a data source to whatever data you have, any database, any storage, files, CSVs, Excel, Microsoft Access, Microsoft SQL Server, MySQL, I don't know, Hadoop, whatever you have, you can connect it. Another cool one that you can, I'm going to go to the weird ones. If you have data points related to a map, you can generate quickly a map and have a visualization. All these free, easy, and open source that you can visualize and easily start generating data. Go and play with it. I highly recommend it, and you will get a blast. You won't believe that this is open source and easy for you and right away available. So I still see the screen somewhat dark. Is everyone seeing it like this? Or is it only me? I am gonna open the chat so that I can check if. Okay, I don't see any comments, so let me stop it and start again because I don't like that it looks like it's a little bit darker than it should be. Well, it looks better now. Let me know if you couldn't see the Grafana dashboards, but I hope that you get a chance to play with them. Now, moving on with the presentation. There's another recommendation with observability. Be careful with it. You can it can backfire if you are not careful and you go crazy with it. Sometimes when we learn about it, like, oh my God, I want to observe everything. I want to have all the instrumentation, all the telemetry, all everything. But there's a term that you can drown in observability. Imagine your car. If your car was telling you every 10 seconds the speed at which you were moving, that would be too much data. Like, I don't know, imagine the voice of Siri, of Alexa, or something like that. You're moving at 10 kilometers per hour. Now you're moving at 12. Now you're moving at 15. Now you're moving. It will drive you nuts. And this is what can happen with observability. You don't look at it all the time. If you were looking all the time your speed in your speed meter in your car, you would crash right away because you need to pay attention to the road, not to the speed. So, first recommendation is to measure only what is indispensable, only what you know that you are going to need. There are all sorts of random things that we can measure. How dry is the dirt here in Mexico City in front of my house as part of the weather app? But I don't need that information. So just measure what is super important. Make sure to send alerts when one must observe, one must pay attention. Like with the car, if you are going faster than the speed limit, I want a bling bling or something to tell me, hey, you're going too fast. Hey, you're running out of gas. Hey, your tires are uh, getting flat. So I don't want to be checking the tires, checking the gas, checking the speed all the time at every moment. But now be careful with the alerts. When you configure the alerts, don't overdose on them. It's easy. If anyone has been on a data center and there's an outage, you'll be paged like, hey, there's an outage. Hey, there's an outage. Once you are notified, is this really important? No, I shouldn't have this alert. Or if you're already alerted, don't make it alert you again and again. For this, you can use the power of SLOs and SLI, service level objectives, service level indicators, which is like, okay, what is the objective? So that your car doesn't go faster than 100 kilometers per hour, because that's the speed limit of this highway. Okay, that's it. Configured. Alert me when I'm going faster. Good, easy, straightforward. And I am exploiting observability. Same with the watch. Tell me when my heartbeat is about to have a heart attack, or I don't know, multiple things. Another thing super important with observability, make it accessible so that everyone can see, in the team and the organization must be able to consume it publicly, not to generate a PDF, not to create a report, but no, you must devise ways in which everyone can see it easily. And what about QA? Because I have been mentioning here and there the deal with QA, but what can I do? What is the deal with it? So there are so many uses that we can do. First, we can make our own software to report a defect. This is instrumenting unit tests, integration tests inside of our system. Our unit test should be part of the software that we have inside. If it's embedded in the software, we will know when something happens. As well, if we put observability in our automations, when they are executing or when they are done, they will easily report and let us know when they are done, pass, fail criteria, what happened with the results. This should not be trapped in a Jira, in your Qtest, ALM, whatever platform that you use. No, it should be available for everyone, because with this, you will be able to automate, I don't know, continuous integration cycles that can pull that information, or you can have a report quickly. Now, with this, as I mentioned, you don't have to create reports continually. Good observability is an automated report. I don't have to put together a report of what is the weather in Mexico City for you to see every time. No, it's automatic. It refreshes. It's quick and easy. You could see that with your QA tests, your results, your cycles. What is the status? What is the performance? All that can be automatically without the manager pinging you for a report every end of the sprint or every cycle, right? Now, another big advantage is that our automations can report their status. Hey, I have an exception. I couldn't find this selector. Oh, okay. So did the automation break? Did the system change? The automations can report this and let you know when they are broken without you having to run them. Um, Also, we can know what is the status of the users, the front end users. We can implement and instrument the browser and then have some information about the user experience, if they are experiencing errors, defects, if the performance is slow. This is available through real user monitoring or adding some libraries to your front end in your web application. And even if it's a desktop application, we can gather the defects and what is the experience of our users. We can also instrument our software to let know our automations that something is about to break them. Before they even notify that they are broken, your solution, your system, your Java application, whatever you are developing, is saying like, hey, I have new selectors. You'd better be prepared. Update your automations, or it's changing here, and there. Now, um, the last, well, performance, Senor Performo, I had to talk about performance. Your applications can also, with instrumentation, with telemetry, with observability, report what is the performance with you having to do an automation. Many times, the reason why we do automations is to know the performance. Well, the system is reporting automatically. It's super useful so that the system tells us what is the performance of our application. So let's go to some tips and recommendations for QA that I give you so that you can embrace and take advantage of observability in your QA efforts. First, instrument your software. The Java application, Python application, Golang, whatever you are creating the application in, instrument it, enable telemetry, store the results, store the situations through agents in the software, through instrumentation. In the software, we can also instrument the test. As I mentioned earlier, you can add client libraries to many of your automations and have this on every environment, every test type, every process. It's super important. If you have this capability, all your test automations will report what is the status of the system, and the system itself can also report the status. Now, with the results, these metrics, these traces, these logs, never hoard them. Never let them be trapped inside of a tool, inside of a platform, inside of your Jira, inside of your Q-test or whatever, your X-ray. No, don't let these results be trapped inside of that platform. Make them put them in a central location so that you will be able to share it with anyone on the team, whatever needs it, person or system, because your continuous integration platform may also need them. Now, once you have observability in your teams, it's very easy to integrate QA into that observability. When you already have observability integrated, instrument your tests, especially the unit tests, your integration tests, your functional tests, performance tests, even penetration tests. If you have your front end instrumented, you will be able to get observability even from exploratory tests. You will know what was the situation. So it's really, really powerful. And make sure to send those results, make them available to be visualized and shareable. Super important. Now, oh, I don't know why I have this title in Spanish. Sorry for that. Continuous improvement of QA. When you are implementing some of these things in QA around observability, you gotta be mindful of what metrics will be useful for you. That your tests, your software generates which metrics do I need, which old metrics or silly metrics that I might not be needing. When last time we got a situation, well, can we create an alert for that? Yeah, thank you. Next time that we have the situation that probably we have had every month when we restart the system, something breaks, we'd better get an alert. Check what things waste time, like the reports, what is repeatable, what is something like silly that I'm like, oh my God, it's second Friday of the sprint and I have to put together this report in a PDF for the manager. Blah. No, those time waste steps should be or can be solved through observability. And last, you can identify what are silly recurrent processes, again, like the report, or hey, I have always to connect this. You can um, help to attain them through observability. Now, I'm seeing the time, and I hope that all this, I was going to say sounded good, but looked good because it's observability. I hope that you liked this presentation. I hope that you got a lot of information out of it. And please, if now that we are about to start the Q&A, you have any questions, you want to follow up with me in socials, you want to like and subscribe the YouTube channel, check the book or any other thing, here's this QR code. You can scan it and you'll be able to get all the information that you need that you may be useful for you. And yeah, with that, thank you very much for joining this presentation. Thank you very much. I hope that all this observability information was very useful for you. and that you got a blast, or at least you got entertained, or that my voice kept you awake. I don't know. I know it's late on some places, so thank you very much.
Awesome. I'll just give it a check in the Q&A tab. Question, we currently are having two questions. Okay, I'll pick up both of the questions.
Hmm.
So the first question is it something the new infra team does in any organization? Who is the current owner of this activity? Question.
Well, uh, infra has, I would say, always had observability available one way or another, not especially how I am I describing it. And in organizations, it depends. I wouldn't say it's a rule like just infra should have it, just DevOps should have it, just, I don't know, SRE. Every team can have a piece of this observability functionality. I don't see why the observability generated by the QA team might be useful for, I don't know, the infrastructure team. So you can have like a global platform for observability,
Mhm.
but what is happening nowadays, every team is generating what is useful for them. And when there's like a um, intersection of like, hey, SRE may be interested on the metrics and observability from QA, we can get some gaps there and collaborations with the teams. But yes, sometimes infra has this, but ask around. I wouldn't give a hard set in stone recommendation or of who has to own this. It's a team task.
Awesome. Next question we are having, question is asked by Rakesh. Do we have an option to configure multiple database, prefer live monitoring and prefer server DB? I don't know if the full form is, I think it's performance live monitoring, right?
Yeah.
And pointing to the single data source in Grafana.
Yeah, Grafana, you create a dashboard and you can configure data sources. So if you have multiple databases, you can pull all the databases into a single dashboard or into a single query so that in a single panel, the panels that I showed you earlier, can be displayed. So, and that's the big advantage because some other platforms, no, you can only see the metrics that you have in Jira. No, you can only see the metrics that you have in this other platform. The advantage of Grafana is that you don't have to be jumping around in different platforms or solutions. Just one Grafana, create many data sources, and put everything to a single dashboard. And yes, you will be able to see it. One, live monitoring, yes. And you can also look at past statuses to know, like, hey, was the server having troubles last week? Oh, yes, it had. And you can get together all the information, even if it's in your AWS metrics, if it's from a CSV, some performance tests generate metrics, and again, in Influx or Prometheus, so you can pull it from there. So yeah, you can pull to from multiple data sources at the same time.
Awesome. I think there were only two questions. Yeah, that is it from my side. Folks, please make sure you folks are filling up the feedback form. This will help us to make sure that your experience in the upcoming sessions is better. Okay, I think there was one more question, folks. We will be picking up this
Mhm.
with the last question. Adding to the same question as the Rakesh mentioned, do we have comparison of result from Grafana like last week? I think this meant Liana, you mentioned this, right?
Yeah, there are multiple functionalities that you can in a single dashboard. You know what? Let me show you right now. I can give a quick display of what I'm talking about. I think it's this one. Okay. So you can see here the panel that I was showing with the map and all the cool things. So if you have like a time series, which is the most common in performance with, I don't know, a few errors, and you have this time frame of what was happening, and you want to see, let me back to dashboard. Now I have this panel here, and I want to add a second one for last week, I can just add a second one, visualization, and I don't know, put another set of information. Again, the random walk. Let me just quickly refresh this because it didn't pick. Come on. CSV file. I don't know. Random walk. There you have it. Back to the dashboard. Now we have two panels together. Probably this is today and the lower one is last week. Or if you want both in the same panel, you can also do that. We can add quickly to this one. We can add another set of fields. I think I was using the errors on this one. Here. So now you have both panels together showing two different sets of information. You can have a different time frame and compare, hey, what happened last week or last run to against today's run. So yeah, the capabilities and flexibility is impressive. Give it a try. You'll be amazed.
Yeah. Awesome. Thank you very much, Leandro. I think all the members had a good time here, and we hope to host you again in the upcoming months. Testix is also coming in 2 months. We'll surely let you know. Awesome, folks. Thank you very much. It's 10:35 here in India, IST. Okay. So I'll be taking a leave. Thank you very much, Leandro, for coming, and thank you each and every one of you for taking our time. I will surely meet you in the upcoming session. Okay. Awesome.
Thank you,
Thank you,
everybody.
Leandro.
Have a good night. Have a good day. Take
Bye
care
bye.
and reach out to me. Like,
Yeah.
subscribe, all that.
Bye
Take
bye.
care.
Yeah.